All right. So for the first part of our agenda, which will focus on our curriculum and academic programs, we are joined by the faculty chairs for both our undergraduate and graduate programs. Justin Eldridge is a teaching professor at HDSI and is the chair of our undergraduate data science program. And he will be followed by Professor Yusu Wang, who is the chair of our new graduate programs, which includes both master's and PhDs in data science. Next, you will hear from Kelly Jensen, who leads our career services and alumni relations at HDSI. She'll share about our student demographics as well as the services that she provides to both our students and employers in terms of connecting with talent. And we are also thrilled to have one of our key industry partners joining us today. Peter Telleroli is a senior consultant at Deloitte and has been really involved with HDSI over the last several years now. So really looking forward to hearing from him as well. And then lastly, I'll provide just a brief overview of industry relations at HDSI and as well as some details regarding our industry partnership program. And then we'll wrap it up with some Q&A. So with that, I will hand it over to Professor Eldridge, who will kick off the presentation this afternoon. So thank you.
Great. Thanks, Eric. Really happy to be here. Before I get into a bit about the undergraduate program, I'll give some history about HDSI. So HDSI was conceptualized and founded by a group of faculty from across UC San Diego, from other departments like computer science, cog-sci, math, electrical engineering, really from a wide array of departments. They volunteered to create this or visualize this institute, which could be a meeting place for data science across campus. Out of that came the data science undergrad program. That was launched in 2017 with, I think, 2-3 classes that we kind of bootstrapped from and created classes kind of on the fly. We had a very small number of students who transferred from other majors into data science in 2017. And from then we've just been growing exponentially. So HDSI as a unit was founded in 2018, and that allowed us to hire faculty into the institute directly. So before that, faculty were hosted in other departments. Now we have a lot of faculty who have joint appointments in HDSI or maybe in, cog-sci or CSE, so forth. But we also have faculty who are hosted entirely within HDSI, and I'm one of them. In 2020, we had our first graduating class of 50 majors and 13 minors. This last year, we graduated something around, I think, 180. And we're looking forward to this upcoming year in fall 2022, having about 900 total majors. So currently there are 657 continuing majors. That doesn't count the group who just graduated. And then we'll add 261 incoming students to that. And we have 200 some minors in data science as well. And as Yusuf will mention later on, we also just launched grad programs, a master's in data science, an online master's in data science, joint with computer science department, and a PhD program. So Kelly, we can move to the next slide. So I'll talk a little bit about the philosophy of data science at UCSD. You may have heard that data science is some combination of computer science and statistics, and I think to first order that's true. But at UCSD, we really think of data science as being its own unique discipline, similar to how computer science started in math departments in the 1940s and 50s, but then kind of grew into its own discipline and its own department at many universities. Here, data science is its own entity, and we treat it as such. And so what that means is our students take, when we look at the major courses, the core required courses, they're data science courses. They may take a couple of classes in the math department, and they may take a CSE class, but the majority of the classes they're taking are bespoke to data science. They're taught by people affiliated with HDSI. So, the three sort of pillars of this, they learn some practical programming skills, They learn some theory in math, in probability and statistics and in machine learning. But we also require students to focus on a domain to learn about some data generating process, because we know data doesn't come from nowhere. We have to understand the mechanism that is generating the data in order to be able to analyze it responsibly. Okay, next slide, please. So as we all know, data science is not a very straightforward process. Most of the time, we don't go directly from a hypothesis to insight in this very linear way. Oftentimes there's sort of a cyclical process, and it requires a lot of critical thinking about our data. And when I joined HDSI back in 2018, I think there was a question of, can students with an undergraduate degree in data science go and do data science upon graduation? Can they be hired as data scientists? And looking back, when the term data science was probably first coined, what was that, maybe the mid-2010s, data scientist was often someone with a PhD, not necessarily in machine learning or computer science, although there were some, or statistics, but maybe like psychology or mechanical engineering, a field that if you think about what the PhD was training, in addition to specialized knowledge in psychology, for instance, it was training you to think critically about data and how to navigate this sort of this messy workflow. And I guess the question is, how do we teach that to undergraduates in 4 years? It's an ambitious project, and the philosophy that we adopt is we have a sort of project-based curriculum. So we can move on to the next slide and see how that works. So every year, every 2 years, we have what I think of as sort of a mini capstone. So at the very first class our students take in the major, it's a project-based course where students are on one hand learning pandas. So the very first class they're learning how to program in Python and how to use pandas. We teach a simplified version of the pandas API, which we call baby pandas. And that's a project-based class where they're learning how to, for instance, create confidence intervals with bootstrapping. That very first class, after they take that class, they have some idea of what data science is about, and they can go and do a project, although the projects in that class are very constrained because these were high schoolers, 3 months ago. After they take that class, we teach some practice. We go deeper into programming. So students take a course specifically in Python programming and then a course in Java. And then they also learn some theory. So probability, some statistics, some computer science theory, like analysis of algorithms. And then after they have that background, we reconvene in a class called DSE 80 that students take usually at the end of their second year. And this class is a fantastic class for preparing for industry internships. I mean, we've heard this from tons of students. They take that class and they come back, they do an internship and they say, I asked them because I run the DSE 197 curricular practical training class, which a lot of students take, where they get credit for internships. And I surveyed them, I say, what class was the most useful for your internship? And about 95% say this class. And in this class, they're learning things like working with web APIs or scraping data and the relative merits of each, how to deal with missing and messy data, so imputation and how certain imputation methods might not be appropriate for a certain type of missing data. They might bias your data. And a lot of things like this. So this class is, again, sort of a project-based class that it's like that intro to data science course, but now they have a lot more theory and programming ability under their belt. After this, they go into the upper division. They take, in their junior year, they take 3 or so machine learning courses, 2 machine learning and a data mining course. They take probability, statistics, and they take data systems courses. So this is database systems, scalable and parallel systems, and a visualization course. And then after their junior year, the theory is they've got all of their core classes out of the way, and they can focus in their senior year on what is a hallmark of our undergrad program, which is the Capstone project. So it's a large major in terms of, comparing it to other majors on campus. This has a lot of courses. Like I say, it's fairly ambitious. It's very rigorous. They're taking a lot of math. But yeah, I want to talk about the capstone now, because like I say, that's. So I guess that's the next slide. So I'll talk about the domains here for a second. So the domains we have, whenever the undergrad program was conceptualized, it was considered very important that students just shouldn't learn data science in a vacuum. They shouldn't learn probability and statistics, but they should also learn about a data generating process, so that whenever they're doing the data analysis, they can understand, okay, why might this data be missing? What are the types of messiness in my data, and so forth. So we give students a wide variety of classes to choose from to build their own domain, but broadly speaking, they fall into 4 tracks: natural sciences, social sciences, business analytics, econometrics, and also a machine learning and AI track, which is very popular. So students there are taking more AI and machine learning, going deeper into those areas. Okay, now we can move forward. Okay, so just to sort of recap, year 1, students are learning a little bit of statistics through simulation, so not too much theory yet. They're learning how to program. So after the first year, students know how to program in Python and Java. In year 2, students focus on theory, and then they take that DSE 80 course, which really prepares them for internships. And then in year 3, they're going back to learning more theory in machine learning, stats, and also in data systems. And then in year 4 is the capstone. So now we can talk about on the next slide. Okay, the capstone. So like I say, the capstone is, I consider, the hallmark of our undergrad program. So this is a 2-quarter sequence where in the first quarter, so first of all, students are paired up with a faculty mentor or a industry mentor. So we have several industry partners run a capstone domain. Deloitte is one of them, as you'll hear. And each mentor might have 5 to 10 students. So it's a very, the student to faculty ratio is quite good. And the goal is for students to really get to know the faculty and vice versa, and for them to do a real data science project from start to finish. So in the first quarter, usually this is for instance, a paper replication where the faculty member might pick a paper that students should try to re-implement and recover the results from. But in then quarter 2, students branch off. They pick a tangential project and they implement it from start to finish in a team. So you can see this, a few examples of capstone domains. The one I ran was spread of misinformation. So we downloaded millions of tweets using the Twitter API and analyzed how misinformation spread across Twitter. But there are tons of very interesting capstone domains, and students have really impressed with some of the projects they've created. And I'll reiterate that this is one way that so some of our industry partners have engaged with HDSI and with HDSI students. And so we're always looking for industry partners to help run capstone domains. And also, just generally speaking, another way people from industry become engaged in HDSI is teaching classes. So we have a couple of our classes which are often taught by people from industry. And I think it's a really good opportunity for our students, especially because they're getting that, they're not just getting an academic view of data science, but an industry view. And I know our students really appreciate that. Okay, next slide. So with that, I'll hand it off to Yusu, who will talk about the grad programs.
Thank you, Justin. All right, so welcome. As Justin already mentioned, so this is a really exciting year for us at HDSI because we're launching 2 residential graduate level programs, the PhD one, master, and also online master program, all in fall 2022. So in less than a month, we're going to welcome our first cohort of around 100 PhD and master students, essentially selected from close to 1,000 applications in this first year of the launch. So we're really excited about this. Now, as I mentioned here, we also have an online master program, which is jointly with Computer Science Department. So this one is designed to target working professionals who are seeking to transition into expand their expertise in data science. So in what follows, I will not focus on this program, rather I will focus on the two residential graduate degree program we have, the PhD and the master program. So Kai Hofer, I think, is here, can also help to answer questions on this online master program. Okay, next slide, please. All right, so we already heard from Justin. I mean, he gave an excellent presentation on data science curriculum design at undergraduate level, and also the important three axes, CS, math, stats, and domain science of data science. Now, to illustrate the curriculum design at the graduate level, I want to revisit this question of what is really needed in a good data science education in our modern time. Because after all, if you think about it, actually data has been with us all the time, okay? And the data analysis is also not new. And you think about it, and mathematics actually used to be one of our major ways to make sense of data, to do calculations, to do hand computations, just like how we track and predict the trajectories of celestial bodies in the sky. Okay, and 150 years ago, of course, we start to have statistical analysis, which play an important role in data, in help us to analyze data. Then the last 60, 70 years, computer science help us to make another leap in our ability to handle very complex data. Okay, now, so this is not new. We have a long history of analyzing data. But in recent years, the ubiquity, the scale, complexity of modern data we're now seeing really has gone far beyond what we have previously imagined. Okay, so at the same time, we also see a lot of tremendous advancement in hardware and new analytical tools, such as the surprising success of deep learning using GPUs. Okay, and also as mentioned by Justin, data analysis is no longer an isolated task, and this the question at hand are often compounded with considerations of data privacy, society issues, and also domain science. Okay, so with all these new challenges, so we're really at a critical moment where we want to consolidate this emerging field of data science, which of course there's no consensus what that is, but in my view, important component is how we can understand and make inference of the world around us through data using modern tools that can combine the computation, mathematics, statistical analysis. Okay, so the goal of our data science graduate program essentially is to build a solid foundation for this new discipline, as well as educate future leaders and workforce in the field. Okay. So note that we're not just producing workforce who can implement, say, another architecture or tune parameters. That is not what data science is about either. Our graduate program, we really want to produce someone who understands the design principle, who know how the architecture interacts with your optimization, as well as data distribution, and also the structure of the input. Okay, so these are the people we hope to develop into major players of the field that help to shape the future of data science, both in academia and in industry. Okay. And we really want to educate people who can push the frontier of data science across science and engineering. Okay. Now, to achieve this, we have to build the foundation of modern data science, which, as already pointed out, has its roots in multiple disciplines: computer science, mathematics, statistics, and computer science, especially algorithms, both algorithms and the system design aspect. Okay, because these are our modern language to develop scientific methods for data. Okay, We also need to take a holistic view of data lifecycle, which is also mentioned by Justin, and also take application fields into consideration so that we can really model and tackle the challenges of real practical impact. Okay, our graduate program essentially is designed to show that the whole is greater than the sum of its parts. Next slide, please. So here are some key components of our graduate program. Okay, so first, to embrace the diverse foundational needs of data science, and also to prepare that our incoming students might have very different background, even though that we expect most of them have the typical mathematical and programming preparation in the quantitative analysis field. Okay, but to prepare them better with a solid foundation, we develop a list of so-called Group A, kind of foundational preparational course to help students to build potentially missing background that they need. So for example, someone with a computer science background may come without a strong background in, say, optimization and probability and statistics. Okay, or someone with a math background may need more catch up with the programming aspects to prepare for data science. Okay, so this is Group A, mostly to help them to build their the needed background. Okay, next slide, please. Now, the core part of data science graduate program curriculum is this Group B courses. You can think of this as the core courses. So this will cover the key pillars of data science. All data science PhD students, for example, have to take the following 4 required core courses, which is listed here on the left. Okay, so this 4 required course covers what we consider to be the main axis: machine learning, statistical analysis, algorithm, or systems, and plus an additional one. It's data assets and fairness, which we consider to be an integral part for someone to carry out data science nowadays. Okay, master students have to take 3 out of this 4 instead of all the 4, and we also have a list of other core courses that students altogether, all graduate students have to take at least 6 courses from this core group. Okay, so this is one of the foundational part of our data science education at the graduate level, right? Okay, next slide, please. Now, we also want to balance the core education with the need for students to learn advanced topics and cutting-edge progresses in data science. And for this, we provide a range of elective courses. What I'm listing here are all the elective courses that data science or in-house given by data science faculty members, but students also have options to take certain numbers from outside data science, from computer science, from electrical engineering, and so on. So there are also specialization courses. There can also be specialization courses in certain application domains, including bioinformatics. Okay. Now, I forgot to mention that all the courses that I'm showing here, these are all redesigned. This is not taken from, let's take this one from computer science and take this one from statistics. For example, the algorithm for data science, which is one of the core courses that I mentioned in Group B, this is actually, the focus is very different from a typical algorithm that you would see in computer science. Instead, here, we focus on aspects that are typical that we see in analyzing modern data, including streaming algorithms and the handling of noise. Okay, so this perspective and the focus of the course is very different from algorithm course from computer science. All right. So okay, so this is the Group C courses electives. Next slide, please. So these 3 groups of courses, A, B, C, from preparational course, the core foundation course, and electives. This essentially covers our curriculum design. But let me also point out that in order to better suit the need of modern data science, we also require all incoming PhD students to participate in the so-called research rotation program in their first year. So year one, every PhD students are financially supported by HDSI. And during this time, for the first 3 quarters, they're required to do 3 rotations, 1 per quarter, with at least 2 different HDSI faculty members. So the goal is to really expose the students to this broad field of data science that can range both from methodologies to domain sciences. Okay, so even for someone who has their mindset saying that I just want to work on data science methodologies, but we still encourage them to do 1 rotation with someone on the application side, from the domain side, so that they get to see this entire pipeline, this whole life cycle of data. Okay. Now, other than that, as I mentioned, students also have to take, all graduate students, both PhD and the master students, they all have to take a course on data ethics and fairness. For PhD students, they also have a special requirement on generalization, reproducibility, and responsibility for the final dissertation. Okay, so these are all we consider to be key components in data science. Okay, at HDSI, I'm not listing them, but we also offer some professional preparational courses to help students' career development. Okay, all right. So this is basically finished my short presentation on the data science graduate program, and welcome to questions later. But let me just end by saying that we're currently at this exciting time with this emerging field of modern data science. The development of HDSI's data science graduate program is really timely, help to put HDSI and UCSD at the frontier of data science nationally and internationally. Okay, but it also took several years of hard work and efforts of many people here at HDSI and UCSD. Okay, but of course, this is we're really excited with our first cohorts of students, but the program itself will likely to continue to evolve together with the landscape of data science. Of course, we're excited about what our graduate program already has to offer, and very much look forward to see its growth in the coming years, but we'll also love to hear from you on comments, feedback, to help us to further improve the program. Okay. So I'll pass this now to Kelly. That's all my presentation.
Thank you, Yusu. I just wanted to share a little bit of information about our student demographics. And as Justin mentioned in the beginning, we have over 900 majors currently, as compared to the first graduating class with 50 students. So you can see it's growing really fast. We have a pretty large international population, just over 37%, as well as 15% first generation status, and a good amount of transfer students as well. And you can see when you look at the gender statistics, they're not balanced between male and female so much, but it is changing over time. And we actually have a dedicated staff member, Sarah Nadiri, who does a lot of outreach to underrepresented communities to expose STEM opportunities and the programs that are offered through HDSI as well. So that's pretty cool. As for the graduate programs, we have 111 total coming in with these 3 different programs. And you can see there's even a larger international population, with 66% being international students across these 3 programs. The cool thing you also see on here is the gender is much more evenly dispersed in the graduate program, so that's nice to see as well. I'm also going to talk a little bit about career services that HDSI has to offer. So I work as the career advisor and alumni and employer relations specialist. And so in that role, I support students, I support alumni, and also kind of serve as a bridge between those two populations and industry. I also work pretty closely with industry recruiters to get an idea of what their needs are and how they want to collaborate with HDSI and engage with our students, as well as connect them with alumni and networking opportunities. To give you an idea of where some of our students end up, these are taken from past graduates, different jobs that they have entered upon graduation. So you can see there's some really great companies on there that our students have gone on to, and some different positions and roles that they are doing once they graduate. And then we also have a lot of students that go on to graduate schools after graduating from HDSI, and some really reputable schools and programs, and these are some of the examples of those as well. We have lots of opportunities to connect with HDSI talent for employers who are interested, or community partners who are interested. You can reach out to me at any point if you have questions, you want to set up a meeting, find out how to engage with student organizations, do an info session to get your information out there. We also do weekly career newsletters where we share information with students on, internship opportunities, job opportunities, career development events, things like that. And so if you are an employer or a recruiter that has positions available at any point throughout the year, we have an opportunity submission form that you can fill out, and we can advertise those positions to the appropriate audiences depending on what the qualifications are and that kind of thing. We also have a LinkedIn page for our alumni, so some of the higher level positions we'll post on there as well. Did want to share too about some of our big events that we would welcome you to participate in. The next one being Data Science Talent Day, which is our largest recruiting event. There's going to be an in-person component of that on October 12th. And there will also be a virtual component, and employers will have the opportunity to do either or both, whatever works best. We are still working on getting the registration set up for that, so look for more details to come. But we are excited about that happening in October. And then we have undergraduate scholarship project program presentation in November. And in March, our senior capstone showcase. So you get to see some of those really amazing projects that students are working on in their senior years in collaboration with a lot of our industry partners. We also have an industry partner alliance program, and Eric is going to speak about that a little bit later. But I am going to turn it over now to one of our industry partners. From Deloitte, we have Peter Telleroli, who I've had the pleasure working with on one of the mentoring programs that Deloitte does with HDSI students. And so I'll turn it over to Pete to talk a little bit more about the partnership that Deloitte has with HDSI.
Wonderful, and thank you so much, Kelly. So as mentioned, my name is Pete Telleroli. I'm a senior consultant with Deloitte, and also a UC San Diego alum from the School of Global Policy and Strategy. But a lot of my work at Deloitte focuses on evaluations and analytics, specifically to the nation's healthcare system and preparing it for disaster response and preparedness and recovery, really focusing on equity in at-risk populations. But I'm not here to talk about me. I'm here to talk about our industry partnership. So Kelly, let's go to the next slide. And it's funny, I was talking to Eric just before this, and it's been 3 years now that Deloitte has been partnered with HDSI, and we've really gotten a lot out of it over the past 3 years. I was kind of thinking through preparing for this, and we've worked with HDSI and a lot of student engagement. We're now active with Capstone projects, and I'll talk about that a little bit later. And we're always looking for ways to talk to them about research or evidence production, or just understanding what it is their faculty members or students are working on and where that aligns with our business goals. And so one of the areas where we've been most successful has really been around student engagement. And as Deloitte, always seeks to build out its AI and data capabilities, we've always had to source more talent from data science schools and students with those capabilities. And HDSI is just a very natural fit for that. And so one of the ways we helped to develop that talent and understand HDSI student capability was around developing a data science mentorship program. And what we do is we pair HDSI students with Deloitte practitioners, and we give them hands-on experience with data science in a consulting environment. And I think over the past year and a half now or so, we've done that for 40 students. And it not only helps us make connections with the students in preparation for our internship and full-time position recruiting, but it's a program our practitioners enjoy and has been a really valuable tool to build those important connections and better understand what HDSI students are capable of. And I just want to mention, when we came to HDSI with this idea, there hadn't been a data science mentorship program before, and they're just incredibly willing partners to work with us and understand our needs and develop something that is very beneficial for the students, but for us as Deloitte as well in terms of what we want to get out of the program. We also do ad hoc events with them pretty regularly. We're looking forward to doing some diversity and data science events in the future. There was a strong interest in Deloitte about that. And we always hold a data science at Deloitte Day to work with students and help them understand what it is we do as consultants with data science, which is really a lot of different things. On the capstones, this is something that Justin had mentioned a little bit, and we've done capstones now for 2 years. And we did it last year, and that was our first year. And we're doing it again this year, but in different domains, which is another exciting thing. So I think one of the things that we've learned internally at Deloitte is that maybe we have a research project or an idea one year we want to focus on, and maybe that domain changes next year. But given how much the HDSI students are doing, always very easy for us to find a complementary capstone for them. And so the first year we worked on one which is really related to modeling and simulation. We had a very small team teach the course, and this year we're doing one related to trustworthy and ethical AI. And the course, for us, it's about a 2-quarter long course, and the first quarter is really more hands-on teaching, and that second quarter is a lot more of applied research project that, as an industry partner, if we have data that we can contribute to that, that's certainly a thing that we can do, provided we have all of our data use agreements in place. And we certainly try to do that because we want to get research out of it as well for our industry and for our organization. There's a faculty member that co-teaches the course and supports us through the course as well. And it's just been very valuable to work with HDSI faculty and students in this area to really help foster areas of collaboration and understand, build those organic connections that, lead to other research and evidence production, which really is one thing we're always looking to do. And we have continuing conversations. If there's something that pops up internally and you say, hey, this could be a good opportunity to talk to Eric and it's a great opportunity to do that and always available. So it's really been an enjoyable partnership for us, and looking forward to continuing it. So Eric, I'll throw it over to you.
Thank you so much, Pete, and really value and appreciate your partnership over the last several years. And it's just been incredible to watch the impact that you have on our students, what they gain from the interactions with, with our partners and Deloitte, and then seeing this this pipeline of talent, having what used to be students in our program are now sitting as practitioners in meetings, a few years later, and that's pretty exciting and gratifying. But I think what Pete just shared really showcases the impact of industry collaboration and partnership for us, and that is really at the heart of the data science ecosystem that we are building here at HDSI. And in fact, it's been, I would say, one of the foundational pillars of the Institute since our establishment. Not only do relationships with employers enable internships and career opportunities for our students, but industry is in a really unique position to offer crucial mentorship and training for our students, as well as exposure to, you know, real world data sets and problem sets. Conversely, developing a data science talent pool with an industry-ready skill set is equally valuable to all of you, to the employers and our partners, especially in a field that is as rapidly evolving as data science. You know, research collaborations involving faculty, industry, and students fuels new ideas and innovation. I think this is particularly interesting now that we have a rapidly increasing number of world-class and to a large extent multidisciplinary faculty. And if you know, also add our graduate programs, this is an additional, you know, pool of talent and expertise positioned to tackle more in-depth and, you know, directed research problems, which we're really excited about. Continued education and knowledge transfer is critical, enabling companies to stay connected to the advances happening in the field and at UCSD, and vice versa, allowing us to stay connected to what is happening in industry. And Kelly, if you could go to the next slide real quick. So to enable these types of deeper collaborations, HDSI has a formal partnership program. It's called the Industry Partner Alliance, or IPA for short. And that's kind of the most common way that organizations formalize their relationship with Institute. It's really designed for companies that want a more comprehensive strategy in terms of engaging with HDSI around talent, research and innovation, continued learning, and playing an active role in our, you know, industry member board and the kind of the broader data science community that we are building. Obviously, talent is probably one of the #1 drivers and motivators. You know, one of the main objectives for us is working with our partners on developing a holistic and sustainable approach to building a pipeline of data science talent for your internship and as well as full-time opportunities. So we want to create those relationships with you early. We want to engage you in different types of events and programs. And we also want to engage you in the skill set development, both soft skills and hard skills of our students. One of the ways that we do that is our industry partners have the opportunity to propose and mentor capstone projects, which both Justin and Pete talked about. So actually bringing you into our curriculum, getting our students working on your data or relevant data sets and your problem sets, and developing those relationships. I would say our partners also benefit from access to faculty members with deep subject matter expertise, and kind of help you all identify and facilitate research opportunities. We also have a lot of different ways where you can stay current with what's happening in the field of data science through different types of events, workshops, speaker series, symposiums, and so forth. And also, as I mentioned, through our industry members or member board that meets on a quarterly basis. We like to invite our partners to bring kind of their thoughts and problems to us, and vice versa, to make sure that we stay connected with what's happening in the broader, you know, in the broader industry space, as well as keep you informed and close to what's happening on the research side. So if any of you have an interest in learning more about that, we'll be sharing some more details and happy to have conversations. And then Kelly, if you want to go to the next slide. After the session today, you'll get a follow-up email with some additional resources pertaining to some of our upcoming events and things of that nature. So keep an eye out for that. And then next slide, Kelly. And then this is the industry relations team at HDSI, in addition to our director for K through 14 outreach, and happy to field any questions or inquiries as a follow-up to today.